Good afternoon. My name is Marcel Campus. I'm from the Netherlands and the Delft University of Technology. I'm going to talk to you today about how we protect coral reefs from space. Coral reefs cover 1% of our ocean's floor, but supports a quarter of our marine biodiversity. They also support over 1 billion people for coastal protection, food, and tourism income. When my team was diving in Bali back in 2014, the reefs were a magical place, brimming with life. 3 years on, it looks more like an underwater war zone. But why is this happening? Well, oceans absorb 90% of the Earth's surface heat, and when the oceans gets too hot, the zooxanthellae becomes toxic, leaving the coral bare to be bleached by the sun, and eventually the coral dies. A reef also cannot withstand the force of a fishing boat dredging through its layers, or a diver that just stamps on reefs. They are just not adapted to that. Economic expansion and coastal developments also have a huge impact on our reefs. Waste and sediments leak out into the nearby oceans, and the algae grow because algae are much better at absorbing large amounts of nutrients than corals. But how do we even begin to study and understand coral reefs today? My colleagues, Marijn, a marine park officer in Sabah, part of the Dutch Caribbean, and Crystal, a marine biologist in Singapore, dive and survey reefs. But this has its own issues in cost, scale, and time. What my team is working on is how we can use satellite data to break the sea-land barrier. By understanding land-based activities and tracking algae growth early on, we can correlate actions and make quick changes. Satellites also allow us to determine whether dark fishing vessels are active, including what type of fishing techniques they use based on movement. We can also zone in to monitor beaches to manage human activities. And in 2017, the Sentinel-2 mission from ESA captured the first coral bleaching from space. All this, in combination with new AI-based software and reef monitoring, goes into an open map showing which coastal regions are most at risk, bleaching, or at recovery. We can then inform and activate local efforts to precisely allocate their resources more effectively for coral restoration. By combining the fields of aerospace technology, computer science, and marine biology, we can use innovation to allow marine ecosystems to recover, which they already do so very quickly by themselves. Lastly, we want to advocate for participatory science so that we can make data about our oceans transparent and actionable. Join us at Reef Support. Thank you very much for your attention, and I'm here to answer any of your questions.